Good evening, sir. Is the screen visible? Am I audible? Yes, thank you. Thank you very much. Right? So, thank you. Thank you very much, sir. Right? So, we are into this data structures course for the past 2 days. Right? So, in the last class or last 2 classes, we have discussed what is a data structure. Right? Then we have seen how many types of data structures are there. Then, right? So what's a data structure? Simply speaking, it's arrangement of data in memory and the operations that we can perform on the data that is present in the memory. We have 2 types of data structures, really speaking: primitive, non-primitive. Primitive are the predefined data types provided by any language, right? They are by name itself saying something. Predefined means how should the data be arranged and what operations have to be performed on the data types are defined by the language. Using predefined data types or primitive data structures, I can create my own data structures. Those are known as non-primitive data structures, like your arrays, strings, structures, unions, right? So based on those, new data structures like stacks, queues, linked lists, trees, graphs, dictionaries. So all these are non-primitive data structures. Under non-primitive data structures, we have 2 types: linear, non-linear. If the data structure is storing the data in contiguous memory locations, physically or logically, or both physically and logically, it can be physically and logically, or it can be only logical. Right? It can be only logically, right? Logically or both physically and right? So they are linear data structures. If the data is not arranged in continuous memory locations, if it is maintaining a parent-child relationship, right? If there exists parent-child relationship between the data, then those data structures are known as non-primitive data structures. Non-linear data structures. Linear and non-linear data structures, right? And yesterday we have seen some examples of for loop. Data structure is a concept, sir. Data structure is a concept. It can be implemented by using C language or Java language or whatever language you know. You have to understand the concept, right? Because whenever you go for interviews, you will be asked to implement that data structure. And nowadays, companies are not restricting that you should implement in this particular language only. They are checking whether you know that particular concept or not. You can implement in C, C++, Java, Python, whatever it may be. Whatever language you know, you can implement that concept, right? So here you learn the concept and you can implement in any language. Here, according to our syllabus, we'll be implementing in C language, right? So there is no hard and fast rule that you should implement only in C. But here, your concentration must be on learning the concept, right? Learning the data structure concept. So yesterday we had gone through a small introduction of an array. What's an array? Simply speaking, it's a collection of similar data items stored in continuous memory locations sharing a common name. Right? So three small points. Whenever I say an array, collection of similar data items. Second point is those data values or items are stored in continuous memory locations. And the third point is all of them are going to share a common name. That is very, very important. All of them are going to share a common name. So every element will be having the same name. Now, the distinguishing part and all those kind of things we'll see when we go by array, right? So whenever I say an array, three common things, 3 points, right? So collection of similar data items or values. They are stored in continuous memory locations. Very important point. And the third one is all of them have a common name. So linear data structure. It's a linear data structure. The speciality is in an array, the data is present in continuous memory locations physically and also logically. That is very, very important. In an array, data is present in continuous memory locations physically and also logically. That is very, very important, sir. Both physically and logically, data is present in continuous memory locations. So how many types of arrays are there? One-dimensional arrays, two-dimensional arrays, and multi-dimensional arrays. So our concentration will be more on one-dimensional arrays and two-dimensional arrays. Right? So we'll start with one-dimensional arrays. So first we have to understand the definition, then convert that definition into the real memory location situation and understand how does an array look like and all those kind of things. Right? So right. So a 1D array is a collection of similar, simple, or user-defined data type values stored in continuous memory locations sharing a common name. Now look at the definition of array and 1D array. Array is saying collection of similar data items. Now those data items, we are specifically defining them, right? We are specifying them. What are those data items? Collection of similar, simple, or predefined, or basic, or primitive data types. It can be termed as simple or predefined, right? Instead of simple, you can write predefined, or primitive, or basic data types, or user-defined data types, collection of structures, collection of unions, right? Those values, right? So similar data items, those data items we are specifying here. It can be not a data item, It can be a simple data item or a predefined data item or primitive data item or user-defined data item. Collection of those items means, example, collection of integers. Your integer is a predefined data type or a simple data type. Floats, doubles, characters, long integers, long double, whatever it may be, the predefined data types or a structure of a student, employee, whatever it may be, user defined and predefined. It can be collection of predefined data type values or it can be collection of user defined data type values. It can be collection of predefined data type values or it can be collection of user defined data type values. Collection of predefined data type values or collection of user defined. It cannot be a collection of an integer or and a student combined together. Sorry, sir. It can be collection of integers, collection of floats, collection of doubles, like that, right? Collection of long integers, collection of long doubles, collection of students, collection of employees, right? Student and employee combined together is not an array, sir. Some collection of students, collection of employees, collection of integers, right? So a one-dimensional array is a collection of similar simple data type values or a collection of similar user-defined data type values, right? So now, if I have to work with something in the language, I should know how to declare it and how to use it. Whatever thing that I learn in the language, I should know how to declare it and how to use it. Now, these basics are very, very important, sir. I should know how to declare it and how to use it, right? So what is the purpose of declaration, sir? What is the purpose of declaration while writing a program? Can anyone tell me, sir? Can anyone answer me? Why should I declare? Now also is the voice breaking? Why should we declare? Why should I declare a variable? Very good, sir. Someone has given the answer, right? Telling the compiler that I require this much amount of memory to work with the values so that I can store in the memory and use it. Very, very important. Declaration. What will declaration do? Very, very simple. Allocate memory, right? Specified by the size of the data type, and that memory allocation will also be given a name so that I can work with the value present in that memory location with the name that I have given. Declaration allocates memory. Not only it allocates memory, that allocated memory will be given some name. The name has to be specified by the programmer only. So what is the advantage of giving the name to that memory location while declaration? Very simple. While I have to work with the value present in that memory location, I'll take the help of the name in order to work with the value. Right? So how will I declare a one-dimensional array? How will I declare a one-dimensional array? So for that, I have a syntax. So syntax, to declare a 1D array. Syntax to declare a 1D array. Very, very simple, sir. We have to know how to declare a variable. How will I declare a variable? With the help of data type, some variable name. Instead of variable name, I am writing some array name. Now, if I write array name, will it become array? No, sorry. Right? So, I have to specify the required number of values. Better, it should be a positive integer greater than 1. Because if I say 1, then it is nothing but a single value. Even though if you don't give 1 also, that will work. If you give 1 also, there is no problem. It will work without you giving 1 also. It will work without you giving 1 also. Right? Now, data type, array name of size. This size should better be a positive integer value greater than 1. What will I give? What will happen if I give 1? It will allocate memory for single value. Even if you don't give that 1 also, it will work. Even if you don't give that 1 also, it will work. Data type, array name, some name of size. Data type, array name of size. What do you want? I cannot answer this question. The administrator will take care of that. Wait 1 second, sir. Yes, sir. What's the problem? Post the question. Right? Why should I declare? To allocate memory by giving a name so that I can store the values into the memory, use the values in the memory with the help of the name. So how will I declare? Data type, array name of size. This size should be a positive integer value greater than 1. A positive integer value greater than 1. Data structures are not for structuring the data, sir. For arranging the data and performing operations. That's the technical answer. Right? Arranging the data in memory and performing operations on the data that is arranged in memory. Right? Not for structuring the data. Right? Arranging the data. And you all should also specify the operations. Data structure is a concept you can implement in any language. Remember that. Right? Data structure is same everywhere. The way you implement with the language, that depends upon the grammar of the language. That's it. Right? So how will I declare a 1D array? Data type, array name of size. It can be some valid identifier. And this size should be a positive value, which should be greater than 1. So we know we are working with simple data types, right? Integer, array name, some A, and it says 5, right? Array name is A, and I am saying it is 5. I'm saying it is 5. Now, so now what do we mean by this? What will happen internally in the system when I say like that? What will happen internally in the system when I say like that? So now 5 blocks of memory will be allocated. So what will happen? Because I am saying 5 blocks of memory will be allocated, right? Every block size is equal to the size of the integer. Internally, what is going to happen? You have to listen carefully, sir. Because I am saying A of 5 blocks of memory will be allocated. 5 blocks of memory will be allocated. Right? 5 blocks of memory will be allocated. Every block size is equal to the size of an integer variable. Every block size is equal to the size of an integer variable. So we are assuming integer size to be 4 bytes because we are working in Windows environment. We are assuming integer size to be 4 bytes, a 32-bit environment, 4 bytes. So if this starts at 20, right? So 20th byte, 21st byte, 22nd byte, and 23rd byte will be utilized by the first block. 24, then 28, 32, 36, right? So the first block requires 4 bytes. Because we are assuming integer size to be 4 bytes, first block requires 4 bytes, 20, 21, 22, 23. Second block also takes 4 bytes, 24, 25, 26, 27. Third block, 28, 29, 30, 31. Fourth block, 32, 33, 34, 35. And fifth block, 36, 37, 38, 39. Right? The first point, right? Similar sized blocks, right? Because I said A of 5, it has allocated, really speaking, 20 bytes of memory. It has allocated 20 bytes of memory. How 20, sir? We are assuming every integer is occupying 4 bytes because C language in Windows environment says that integer occupies 4 bytes of memory. So 4 into 20 bytes. 20 bytes of continuous memory because the definition is saying something. Collection of similar simple data items stored in continuous memory locations. Now see, sir, first value is stored from 20 to 23, second value 24 to 27, third value 28 to 31, fourth value 32 to 35, fifth value 36 to 39, 36 to 39, right? So 20 bytes of continuous memory are allocated. Every block, right? It is divided into 5 blocks because I said 5 blocks. 5 blocks, every block is being given 4 bytes of memory. Every block is being given 4 bytes of memory. And this complete block is assigned a name A. Not first block, sir. All 5 blocks together is assigned a name A. Now, very, very important, sir. All 5 blocks together is assigned a name A. Means the first block's name is A, second block's name is A, third block's name is A, fourth block's name is A, and fifth block's name is A. Very, very important, sir. I said int A of 5. What will happen is it will allocate 5 blocks of memory, right? 5 blocks of memory. And what is the size of every block? Very, very simple. It is dependent upon the data. What is the size of every block? it is dependent upon the data type. So the data type, now here, integer data type. So what is the size of integer data type? Not like that, sir. I have taken an example that it is starting from 20. It will not start from 20, sir. Remember that. It's just an example, right? It can start from 20, it can start from 100, it can start from anywhere. That is not that is not in our hand. That is not in our hand, sir. Very, very simple. That is not in our hand. 1 second. Yes, sir. In Windows environment, it is 4 bytes. In DOS environment, it is 2 bytes. Nowadays, we are not using any DOS environment. So we are saying Windows 4 bytes only. Right? So because in Windows environment, it is 4 bytes. DOS environment, it's 2 bytes only, sir. Now, so I am saying A of 5, 5 blocks. I'll upload notes in the Google Classroom link, sir. You get the Google Classroom link from the administrator. You can see there. I'll upload today only. No problem. And if you observe, they are sharing the video links, right? So you can see those video links also. 5 blocks of memory are allocated. 5 blocks of memory are allocated. Every block size is dependent upon the size of the data type. So here, because we are working in Windows environment, we are saying integer size is 4 bytes. So first block, 4 bytes, and second block, 4 bytes, third block, 4 bytes, fourth block, 4 bytes, and fifth block is 4 bytes. Check your internet connection, sir. Right? Now, very, very important. And all these blocks are given the name A. All these blocks are given the name A. Means first block's name is A, second block's name is A, third block's name is A, fourth block. Now, how will I distinguish them? Now, very, very important. How should I distinguish them? How should I distinguish the first block's value from the second block's value? How should I distinguish the second block's value from other blocks values, right? So to distinguish the values of the array present in blocks allocated, we use the index or subscript which starts from 0, right? So some languages start from 1, some languages start from 0, right? So that depends upon the language. But from C, every language says that, right? But from C, every language says that, yeah, every language is saying that it is the index starts from 0, right? So now, because every block of memory is having the same name, we are using, how should I distinguish them? We are distinguishing them with the help of index or subscript. And that index starts from 0, then 1, then 2, then 3, then 4. Means array with 0 index, array with index 1, array with index 2, array with index 3, array with index 4. So that is how what we are going to do, sir. Array with index 0, array with index 1, array with index 2, array with index 3. Means this is array with index 1, array, sorry, 0, index 1, array with index 2, array name with index 3, array name with index 4, right? Array name with index 4. That is the design of the language, sir, right? That is the design of the language. Index of the array elements starts from 0. Yesterday also one person asked the same question, right? So what is Google saying, right? So the distance of the value from the starting position is, for the first value, it is, the distance is 0. For the second value, the distance is first 1 position. For the third value, distance is 2 positions. Fourth value, distance is 3 positions. Fifth value, distance is 4th position, right? 4 positions, right? It is away from 4 positions. It is away from 0th position, right? But that is not the real answer, sir. The answer is the language has been designed in such a way, right? The language designers, Dennis Ritchie, has said that index of an array element starts from 0. Index of array element starts from 0, right? The second element index is 1, third element index is 2, fourth element index is 3, fifth element index is 4, right? So remember that, sir. That is design issue, right? Now, to distinguish, right? So array, collection of similar data items stored in continuous memory locations. Now, see this, collection of similar data values means all of them are 4 bytes. They are in continuous memory locations, right? They are having a common name. For us to distinguish, I'm taking the help of an index. I'm taking the help of an index, and that index or subscript is starting from 0. That index or subscript is starting from 0. Now, what should I do, sir? I should store the values into it. I should print the values present in it, or I should use the values to perform operations on it. Means, in a way, I have to access. Now, what should I do, sir? My real thing will be, maybe I want to store values into the array blocks. I want to retrieve values present in the array blocks, right? I want to retrieve values and perform some operations on that blocks, on the values present in the array blocks, whatever it may be, right? I want to access the elements of the array. In simple terms, I am saying I want to access. Accessing means what, sir? Storing a value into the array memory block, retrieving the value from the array memory block, or retrieving the value and performing an operation on the array memory block, performing operation on the array memory block, whatever it may be, storing, retrieving, performing operation on the value present in the memory block of the array. So that, in one single word, we are going to say it as right? So we are going to say it as accessing. Accessing the elements of a 1D array. So to access the syntax. Now, what do you mean by accessing? Storing value into a block of 1D array, retrieving value from a block of 1D array, right? Performing operation on a value present in the block of 1D array. 1D array is having similar sized blocks, right? I want to store a value into that block. I want to retrieve value from that block. Right? I want to retrieve value from that block. I want to perform operation on the value present in that block. So to do those things or doing all those things, we are saying it as accessing. Doing all those things, we are saying it as accessing. For accessing, the syntax is array name with index. Array name with index. So array name and index. So that will help us to access. Access means maybe I want to store a value. I want to retrieve a value. I want to perform operation on the value. I'm going to do like this. Means now see, sir. Our example was like this: int a of 5. Right? So this has allocated, or what will this do? This will they have the indexes, and don't think that it will start at 20 only. For it can start at anything, but the thing is they will be in continuous memory. Right? It will start at any position, no problem. Right? So now what are these indexes? What is this array name? What are these memory locations? Very, very important, sir. Right? These are memory locations. These are indexes. This is an array name. If I want to work with this particular block, I'm saying like this: array name of index with this block, array name of index with this block, array name of index with this block, array name of index, array name of index. Now that is very, very important, sir. Array name of index, array name of index. Now, working or accessing means what, sir? Maybe I'm saying reading or storing. Maybe I want to store a value into this particular memory location. I want to read a value into that particular memory location. To read a value, 1 second, sir, 1 second. To read a value, very, very important, sir. To read a value, I will take the help of scanf. To read a value, I'll take the help of scanf. So what is the syntax of scanf? %d, format string, address of the variable name. My variable name is a of 0. Very, very simple. The variable name, the name of this block is a of 0. Right? Name of that block is a of 0. Right? So address of a of 0. Scanf into the second thing, a of 1. Scanf %d, %2. Scanf %d, a of 3. Scanf %d, a of 4. Now, very, very important. Yes, sir. Yes, sir. Please wait. Right? So now, instead of writing 5 times, I know the number of times. I can go for a loop. Instead of writing this many number of times, for some I equal to 0, I is less than 5, I plus plus, scanf, percentile D. We have simplified our task. Right? Means when I is 0, value will be read into A of 0, maybe 7. When I is 1, value will be read into A of 1. When I is maybe 12, 15, 17. Maybe I have given the values like this. I have given the values like this. So dynamic we'll see later, sir. First, let us understand the static basic concept. Right? So I equal to 0, I less than 5, I plus plus. This is what is going to happen. Now, if I want to print, so what will I do for printing? Very, very simple. The change will be like this. Printf, percentile D, A of 0. That's it. Whenever I read, I take the help of ampersand to get the value from the keyboard and store into that particular memory location. If I say directly in printing A of 0, it will go to the memory location, retrieve the value and print it on the memory directly. So that is the advantage, right? So that's it, sir. Printf, percentile D, A of 1, and so on, so on. So instead of writing like this, I can write like this for I equal to 0, I is less than 5, I plus plus, printf, percentile D, A of 1. That's it, right? So this is how I'll be printing. This is how I'll be reading. If you combine both of them, it will be a simple program, right? So directly write the code and understand. Right? So instead of, okay, so let us read 5 only, no problem. And I also require I, if you recollect carefully in the example, we also don't not only require array, but also require I, the loop control variable. So which will help us to move through the loop. So printf, enter array elements. Right? So for reading, no, I equal to 0, I is less than 5, I plus plus, and a percentile D, ampersand A of I. Def, the array values are, so for I equal to 0, I is less than 5, I plus plus, def, percentile D, some place, some space, and A of I. Return 0. That's it. So save. maybe a1.c, array1.c, compile and run. So what is it asking? 5 values. Maybe I gave it as 34 a space, 12 a space, 76, 7, okay, 98, 60. See, it will simply display those things, right? Whatever values I have read, they have been displayed. A simple basic program, right? Where we are understanding, right? Here we are understanding how we are reading. Yes, sir, it will be uploaded, sir. Will be uploaded. Now, the real thing, right? So here our concentration is not on reading or printing, right? So that's a simple basic idea. But now what operations can we do on arrays? Those will be every link. Yesterday's link is also be uploaded, sir, already uploaded. This is what internally happens, sir, right? Scanf percentile D, A of 0, A of 1, A of 2, A of 3, A of 4. Instead of that, I wrote a for loop. In the same way, instead of writing printf 5 times, I wrote, okay, right? Once again, they will share, sir. Don't worry. Once again, they will share, right? So instead of writing 5 times, I am writing a for loop. That's it. If I want to repeatedly execute a task, I'll go for a loop. That's it. Now, what operations can we perform on arrays? Those will be our programs, simply. So the first program, maybe, yes, sir, please post your questions, sir. Print the values of the array in reverse. Maybe the first question. The first question is, okay, why data structures are important, right? But products have operations which have to be implemented by data structures, right? Operations on data, right? Operations on data, right? Operations on data have to be implemented by data structures only, right? So, print the values of the array in reverse order, right? Maybe first, now we have seen, we have read the values and print the values. We have printed the values in the same order. Next, maybe print alternate elements of an array. Sorry, sir. Starting from first position or starting from 0th position or 0th index. Maybe you can try out print alternate elements of an array starting from index 1. Maybe so operations are programs, right? On an array, I can do 3 things: reading, printing, these graphs, everything with the help of programs only. Everything with the help of a program only. We will implement. Practically, we'll implement and see, sir. Everything will be implemented hands-on. Right? But for that, we have to be very good at basics, sir. That's why a more concentration is given here. Right? Find sum of odd numbers and even numbers separately. Here we are finding out the sum of all the elements. Here I want odd elements sum separately and even elements sum separately. That's a separate application. Maybe find maximum element in an array, right? Minimum element in an array. All these are operations, right? Search for an element in an array. Sort the elements of the array. Thank you. Right? Then search using a special technique known as binary search. Right? Then 1 second, sir. Right? So find the second maximum element of an array. We'll see. We'll write programs for all these things, sir. So here, these are the operations. Yes, sir. But more practice, more number of example programs have to be done by you, sir. Right? More number of example programs have to be done by you. Right? So maybe a question like find the leader elements of an array. Now, these kind of questions will be asked. The previous all questions are okay. We can easily understand. Leader elements of an array. Now, what do you mean by leader element? An element whose value is greater than the values present in previous position and following position. Simple example, simple program, but you have to understand, you have to know what is a leader element, right? Whose value is greater than the value present in its previous position and the following position, previous position and following position. Right? The course duration given is 45 days, sir. We'll complete every topic. Till that point of time, course will continue. Right? So, given a sorted list of elements, print all the Pythagorean triplets present in the array. See, sir, right? Array maybe will be having some Pythagorean triplets, right? So I want all those Pythagorean triplets. Okay? So we'll solve these problems and we'll do some more problems also. But now what's the first question saying, sir? I want the values of the array to be displayed in reverse order. Reverse. Now reverse order means what, sir? The first program, whatever we have discussed, is printing the values in the order in which we have given. Means I have taken 5 elements, I have read 5 elements. So those 5 elements are from 0th position to 5th position. For example, right? So this is my array 7, 8, 2, 9, 5. Those are the values that are stored in the array. Now, maybe for reading, I said like this. Was what? Maybe because of this thing, this has happened internally. A of 0, 7 has been stored. I gave 7, it went and stored there. A of 1, 8, A of 2, 2, A of 3, 9, A of 4, 5. Now, printf array values are. So for I equal to 0, I less than 5, I plus plus. So what will this do, sir? Very, very simple. It will print like this. 78295 will be printed. But what's my question? What's my first question saying? Print the values of the array in reverse order. Means what, sir? Values of the array in reverse order means I want 5 to be printed first, then 9 to be printed, then 2 to be printed, then 8 to be printed, then 7 to be printed. Very, very important. First, I want 5 to be printed, then 9, then 2, then 8, then 7. Now, what is 5? It is A of 4. What is 9? It is A of 3. Means my I should start from 4, right? And printf percentile D A of I, right? When I is 4, A of 4 will be printed. After 4, I should become 3. Now that is very, very important. After 4, I should become 3. So now what will happen? How will I become 3? When I say I minus minus, I is going to become 3. So A of 3. Then I should become 2. I minus minus A of 2. I minus minus A of 1. I minus minus A of 0. Then when I minus minus is performed once again, I will become minus 1. Means my process should be repeated till the value of I is either greater than 0 or equal to 0. Till the value of I is greater than 0 or equal to 0. Right? So I equal to 4, I greater than or equal to 0, I minus minus. So this is how we are going to print the values of the array in reverse order. Very, very simple. Values of the array in reverse order, right? So from 0th position to the last position, if I say, it will be printed in the same order in which they are present inside the array. From the last position to 0th position. Whenever I'm moving from smaller value to larger value, I'm incrementing. Whenever I'm moving from larger value to smaller value, I'm decrementing. And in the process of moving to the top value, I'm checking with less than operator. To the bottom value, I'm checking with greater than operator. That's it. You can write greater than -1, but instead of -1, I'm writing greater than or equal to 0. So this program, this will become a program when I add a main function. Maybe I declare a value. I write a return 0. Close it with, yes, sir, you can post your question, sir, please. Yes, sir, what's your question? So did you understand, sir? The reverse printing the values of the array in reverse order. Printing the values of the array in reverse order. Instead of going from the first position to the last position of the array, we are coming from last position to the first position of the array. That's it. Last position to the first position of the array. Now we'll see next two programs also. Now assume array size is 10. So there is no restriction that array size should be 5 or 10 or that kind of thing, sir. Yes, sir. Not like that, sir. Initially, we are concentrating on arrays and strings because nowadays more programs in interviews are being with respect to you want to reverse the values of the array permanently. I will show you. Right? We'll write a program tomorrow. Right? There we have to swap, sir. Right? So we have to swap. Right? So we have to swap the values. Now I'll show you. I'll show your answer. I'll show you the question. Maybe like this. So what you want to do is you want to reverse the values permanently. Means simply do like this. Swap 2 and 4, 6 and 7, 9 and 3, 5 and 10, 8 and 1. That's it. Values will be automatically reversed. Values will be automatically reversed. So for that, what should you do? You see that your value starts from a position starts from I there, position starts from J here, and swap the values. Simply swap the values. Syntax differs. Syntax differs. Concept does not change. Only syntax differs. Right? Here I will be using some syntax. You can use it. Maybe Python syntax is differing for that same concept. C++ syntax will differ for the same. Almost C++ and Java will have the same syntax when you consider loops, conditional statements, right? But the new concepts, they are different, right? For example, in C, strings end with a null character. That will not happen in Java. Java strings are objects, right? They are more sophisticated in Java. But in C, it's a character array where we say it as a string when it ends with a null character. When it ends with a null character. So our question, right? So we'll add this question to our question, sir, right? I will write the code for that. Don't worry. So you want to reverse all the elements of the array. Okay. Right? We'll write that logic also. Don't worry. So when arrays, after we complete arrays, sir, right? So in 2 or 3 days, we'll complete arrays, right? We have to have a strong knowledge of arrays, sir, in order to understand our data structures. That's why a little bit, right? We are learning a little bit slower. That's it. We have to have a strong knowledge of arrays. Remember that, sir, please. Then only it will be easy for us to understand the data structures, right? And so I want 2, 9, 8, 10, 3 to be printed. That's it. Means for from the 0th position. If I want to print 2, 9, 8, 10, and 7, means the values present in 0th position, 2nd position, 4th position, 6th, 8th positions. Means printf percentile d a of I. This will not change. But after 0, I should not go to first position. I should go to the second position. After second position, I should go to the fourth position. After, okay, sir, right? After second position, I should go to the fourth position. After fourth position, I should go to the sixth position. Till what position, sir? Till the size of the array. Till the size of the array. My size of the array is 10. Now this is my, look at this. This is my alternate elements of the array starting from 0th position. The next question is alternate elements of the array starting from index 1. Means the same thing. But the changes see, sir, I can write I equal to I plus 2 or I plus equal to 2. Both of them are same, right? Right? So this is alternate elements. Alternate elements printing. Right? This is starting from index 0. This is starting from index 1. Whatever it may be. Right? Yes, sir. We will learn memory location, pointers, all those kind of things. Right? So, very, very important, sir. We have learned, we have written some 2 or 3 programs only today, but simple programs, right? So, but our concentration was on how to declare an array, what, how is memory allocated inside array, right? Continuous memory locations, how to distinguish them, how to access them, right? So tomorrow we'll complete all these programs and we'll see some more real world programs also. See real world programs also. Yes, sir. Any doubts in today's class? Are there any doubts in today's class? How to read an array, how to declare an array, how to access the elements of an array? Yes, sir. What is your doubt? Q2. What do you mean by Q2? Question number 2. What is question number 2, sir? Alternate. Yes, sir. What is your doubt, sir? What is your doubt in printing alternate elements? Alternate elements. That's it. So alternate elements means I want the value. Yes, sir, we can write, but why should I use a conditional statement when I'm able to do like this, right? When the question is clear and I should increment every time by 2, why should I write a conditional statement and put pressure on the system of checking the condition? That's it, right? So I want the value present in the 0th position, then the 2nd position, then the 4th position, then the 4th position, 0th position, 2nd position, 4th position, 6th position, 8th position. So I'm starting from 0. A of 0 will be printed. After 0th position, I should go to the 2nd position. So 0 plus 2, it will automatically go to 2nd position. Right? 2 is less than 10. A of 2 will be printed. 2 plus 2, 4th position. 4 plus 2, 6th position. 6 plus 2, 8th position. So that is how it is working, sir. Yes, sir. Right? We will be writing in developer C++. Right? So these are simple programs I'm writing here. But if some complicated program comes, a little bit complicated comes, I will write directly in C++ editor. Right? So is your question answered, sir? From 0 to 2, 2 to 4, 4. Now, alternate elements starting from first position. That's why 1, 3, 5, 7, 9. What is your question? You know. Single loop to read and print values. No, sir. So if you use a single loop to read and print values, after you read the first value will be printed. After you read the second value will be printed. Third value, after you read the third value will be printed. You'll get into a confusion. That's why we'll read all values at a time, then print all values at a time. Right? There is no wrong in what you are saying, sir. Right? It's possible. There is nothing. Right? So we can write like that. But what will happen is you will get into confusion while working with the program. Scanf, percentile D, ampersand A of I, and printf, percentile D, A of I. What will happen? So while executing, you have given the first value 1, it will be printing 1. 2, 2 will be printed. 3, 3 will be printed. 4, 4 will be 5, 5. So what is the fun in that? Right? So you have to read once, then print all the values. Then only you will understand what is happening internally. How are they being stored? Yes, sir. Are there any other doubts? Okay. We'll do it tomorrow. Don't worry. Right? So as and when we come, we'll complete that program only. Okay. Then right. If we can solve using for loop, we can solve it using while loop or do while loop also, sir. No problem. Subset. Subset means they may not be in continuous memory locations, but subsequence must be in continuous memory locations. Offline classes, administrator will tell, sir. Mine is an online class. Subset of an array means they may not be in continuous memory locations, Subsequence must be in continuous memory locations. Subset means 1, 3, 5, 7 or 1, 3, 4, 6, whatever it may be. Those positions are subset positions. But 1, 2, 3, 4 will be a subsequence. Yes, sir. Still any doubts? Thank you, sir. Right. So we'll continue tomorrow. This is a course in C, sir. Right. This is a course of data structures in C. So 6, 9, 10 or 8, 6, 8, 9 or 7, 10, all these are subsets. But 6, 7, 8, 9 is a subsequence. 7, 8, 9 continuous memory location values are subsequences. 8, 9, 10, 9, 10. Right? Values present in continuous memory locations. Values present in continuous memory locations are subsequences. Administrator, sir, please post your number, it seems. Right? Values present in continuous memory locations. I think he has posted his number. You can see. For queries, all those kind of things. What is meant by alternate elements? Elements present in alternate positions. 0, 2, 4. Instead of 0, 1, 2, 3, 0, 2, 4 positions or 1, 3, 5 positions. That is alternate elements. Is there still any doubts? Thank you. Good night. We'll continue tomorrow.